So far, we already know all the rules of exponents, and we're focusing in on the second half, rules 5, 6, and 7. But then again, you could have all 7 rules in one problem, as we saw in the other video. So right now, let's go to this worksheet. I'm going to explain the odd ones right here on this video, and you guys are going to do all of them as homework. Okay, so you could follow along with the odd ones, but ultimately you're going to have to do all of them. So number 1, this is rule 7. If we take a look at the rules, rule 7 says cancel out the like terms on numerator and the denominator. It really becomes a subtraction problem. So we do have 6 on top and 6 on the bottom. There's 5 6s up on top. So if you wanted to show your work, you don't have to. 6 times 6 times 6. Okay, that's 5 of them up there. And down here, there's 4 of them, right? So when you start canceling, 6 over 6, Esteban, is 1. Cancels 1, cancels, cancels. The only thing left is 6 up on top. It would be pointless to put it over 1 because anything over 1 is still that same number. So 6 divided by 1 is still 6. So I would just write it as the answer 6. Make sense? And that was rule 7. You don't have to memorize the number. You just need to know how to apply it. Here's another one where we have to cancel out. So what's the answer here going to be? What do you guys say?
X squared.
X squared, right? And is the x squared up on top or is it on the bottom?
Up on top.
Up on top, right? So you could go x squared is x times x. X to the 4th is x times x times x times x. But this is really a waste of time, canceling, canceling. What's the answer? There's x squared left up on top. So the answer is just x squared. The quicker way that I recommend you doing is think about canceling in your head. Don't actually show this on paper. Just think about it in your head. Oh, there's 2 x's on the bottom. All of these x's, both of them, the 2 x's are going to completely cancel out with 2 of the 4 that are up on top. So there's still going to be 2 left over. So that's how you know it's x squared up on top. That's why your answer is x squared. Okay? Let's move on to number 5 here. Again, we're going to cancel things out. What's your answer going to be right here? M? That's it? The answer is M? Sarah, what do you say? This is still rule 7, canceling out. M to the 2? But where is that left over? On the bottom. So what's your answer? 1 over m squared. Okay? Again, if there's nothing left up on top, you have to put a 1. If there's nothing left on the bottom, you don't have to put a 1. Okay? So because there's nothing left up on top, you have to put a 1. So let's go back to this part. Okay? Well, you do have one single m up here. And down here you have 3 of them, right? It's m times m times m. So one of these m's cancels out with one of these. What's left? 2 m's. So it's m squared, and it is left on the bottom. Okay? Now, since there's nothing left up on top, you have to put the 1. It's kind of like, let's say this were the other way around. Let's say let's pretend that we had m to the 3rd up here and m down there. Okay, well this m on the bottom cancels out with one of these, and you'll have 2 left up on top. So your final answer is going to be m squared. And you don't need to put the over 1, because if it's over 1, it's still the same thing. So you could erase that over 1. You could just write it as m squared. So once again, when there's nothing left on the bottom, you don't have to put over 1. But when there's nothing left up on top, you have to put that 1 up on top. It's as simple as this. When you have 1 over 2, you have to have the 1 up there. But if you have 2 over 1, you don't have to have the 1 on the bottom. That's actually just 2. So I kind of went off on a tangent here. The bottom line is, on this single question, the m cancels out with one of these. There's going to be 2 left. So the answer is 1 over m squared. Let's take a look at number 7. So right here, what cancels out, Ismail? This is still rule 7, where you cancel out what you see on top and bottom. Okay, so let's start with the n's first, yeah? How many n's do we really have on top? 5. Now you could write n times n times n times n 5 times, and there's only one n on the bottom. So one of the n's down here cancels out with one of the n's up here. So what I'm going to do is just this. I'm going to put this n cancels out with one of these 5 n's. So I'm going to have 4 left over. Okay? So on top, my answer is going to have an n to the 4th, right? But what else do we have? Up here we have 12, and down here we have 36. I could put 12 over 36, but I know that the fraction 12 over 36, I could at least reduce it, right? I could at least reduce it. So 12 over 36 reduces down to what?
3 to 4.
And let me just go on the side right here. 12 over 36, the answer becomes 1/3. Okay? And there's many different ways of doing this problem. A reducing problem is actually a canceling problem. If you've never seen it this way, check this out. The 12 over 36, 12, it really is 12, right? And you could write it technically as 12 times 1. Now the 36 is really, you could rewrite it as 12 times 3. 12 times 3 is 36. And now that we have a 12 on the top and a 12 on the bottom, you end up with 1/3. Yay? Now, of course, we never reduce that way. How do we normally reduce? We say, oh, there's a 12 on top. I could divide by 12 and I'll get 1. There's a 36 on the bottom. I could divide by 12 and I'll get 3. So it does reduce down to 1/3, which is perfectly fine. But you could also rewrite it with multiplication and cancel things out. So on number 7, the 12 over 36 reduces down to 1 over 3. Okay, because 12 divided by 12 is 1, and 36 divided by 12 is 3. So what I have left up on top is not only the end of the 4th, but I also have the 1 left over right there. So let me put a 1 right here. And on the bottom I have what? 3. That's right, 3. So your answer is 1 n to the 4th over 3, or you could just say n to the 4th over 3. That's your answer for number 7. Okay? Let's take a look at number 9. So on number 9, what could we cancel out? The B's and the A's. All right, let's start with the A's. How many A's could I cancel out? 1, right? There's 1 A down here. There's 3 up on top. So 1A cancels out with one of these 3. Notice how I don't go through the whole thing and scratch out the A. I'm only scratching out the 3 and replacing it with what? With the 2. Bless you. Okay, so 2. Bless you. I forgot. We have A squared on top, and on the bottom, how many B's do we have on the bottom?
2.
And how many B's do we have on the top? 5. So how many cancel out with how many? 2 cancel with 2. How many are left? 3. So we really are canceling out, but we're doing it in our head, right? So you have 2 on the bottom, 5 on the top, 2 cancel with 2. There is 3 left over up on top. What's left over on the bottom? A 1. Is it necessary to write our answer over 1? No, it's not. But if you had a 1 up on top, it is necessary that you write with the 1 on top. But right here, the final answer is just simply A squared, B to the 3rd, and that's it. Let's move on to number 11. So on number 11, we could even take a look at the numbers first, the coefficients, right? It's all pure multiplication, so you could cancel things out. So let's take a look at the number negative 21 over 7. And remember, over means divided by. So could you actually divide negative 21 divided by 7? Yes. What's the answer? Negative 21 divided by 7 is?
3.
Negative 3. Now, where is that answer left over? Is it up on top or on the bottom?
On the top.
It's on the top. Now, if this is confusing to you, what you could do, what I'm going to do is I'm going to make this 7 a blue 7. And I'm going to make this negative 21. I'm going to rewrite it as 7 times negative 3. See, that's the same thing as negative 21. And then you could say, okay, this 7 up here will cancel out with this 7 down here. So what's left over? My answer has a negative 3 up on top. Does that make sense? Okay, now let's go for the W's. You have 4 W's on the bottom, 5 W's up on the top. All 4 W's cancel out with 4 of these 5, and you'll have 1 left up on top. Does that make sense? So I really just have a W. You could put to the 1 power, but that's unnecessary. You could just, the W means that it's to the 1 power. And how about the X's? You have 2 X's up on top, all these 2x's completely disappear with 2 of the 5. And how many are left? There's 3 left. And where are they left? On the bottom. So you really have the x to the third left over on the bottom. So this is the answer right here, negative 3w over x to the third. I guess you could also write it like this if you wanted to. You could put the negative out in the front of the fraction and just put 3w x to the third. So you could put that negative sign that's up on the numerator, you could put it out in the front of the fraction if you wanted to. But either way is perfectly fine. Move on, number 13. Finally, we get to a different rule. So far, all we've done is rule 7 where we cancel things out, right? So right here we have rule 3 or rule 4 if you want to call it. The only difference between last week and this week is that this week we have a fraction on the inside. So it's the same thing. The rule says if you have parentheses with an exponent on the outside, distribute that outside exponent to each inside exponent and multiply the exponents because of rule 2, power to a power you multiply. So we're still going to do the same exact thing as we did last week, distribute. The only difference is that we have numerators and denominators here, a numerator and a denominator. So the 4 is really to the 1 power, 7 to the 1, and we're going to take this exponent on the outside and distribute it to each and every exponent on the inside, which we end up multiplying. So you end up with a 4 to the 2nd power. And then you distribute that 2, multiply it by 7, you're going to end up with a p to the 14th power, right? And then it's going to be over, then you're going to take the power of 2 and multiply it with that power of 1, and we end up with 7 to the what? 2nd power. And last but not least, we're going to end up with the 2 being multiplied with that 2, r to the what? 4th power. Now, that's our answer, but is there anything else that we could do?
Yeah.
What? And what is 4 to the 2nd? That's 16. Okay, so my answer is going to have a 16 up on top. And the p to the 14, we're just going to rewrite it. And on the bottom, what's 7 squared?
49.
That's 49. 7 times 7 is 49. And then the r to the 4th, I just bring down again. So this is our answer. Could I cancel out the p to the 14 with the r to the 4? No, those are different terms. You can't cancel, right? Could I cancel out the 16 and the 49? If you could reduce it, you reduce it, but you can't reduce 16 over 49. You can't reduce by 2, can't reduce by 3. That's as much as you could do. So that is your final answer for this problem number 13. Let's move on to number 14. Sorry, not 14, 15. We're doing the odd ones. Yes, finally getting to rule number 6. When you have a negative exponent, you move that term from one side of the fraction to the other side of the fraction and make that exponent become positive. So you're probably thinking, we don't even have fractions here. You're right, it's not a fraction, but you could put it over 1 so it'll look like a fraction, right? Now, it does have a negative exponent, so you could take this whole thing, I like to circle and draw some arrows, and move it to the bottom. So our answer is going to be a fraction with 8 to the positive 2 on the bottom. Remember, when you move it, it becomes positive. Now, since we took this and moved it down, what's left over up on top?
1.
A 1. There's nothing there, so we have to put a 1 up there because there's nothing there. And this is our answer, but what else could we do? 8 to the power of 2. So what is 8 to the power of 2?
64.
64. So your answer is really 1 over 64. And that's it. 17. You have 2 rules right here. You could pick from these rules. You could either do rule 3, which is rule 4, where you take the outside exponent and distribute it to each inside exponent, or you could do a shortcut. Whenever you have parentheses with an exponent that's negative on the outside, you could flip the inside fraction and change that to a positive. I know you guys are probably thinking, what? That sounds really confusing. Let's actually distribute the way we would normally do it. So you're going to end up with 9 to the negative 1 and 11 to the negative 1, correct? If you distribute that negative 1? Yes? Okay, and then the other rule says if you have a negative exponent, you have to grab it and move it down or move it up to the other side. So your final answer is 11 to the positive 1 up on top and 9 to the positive 1 on the bottom, which is 11 over 9. Are you with me? Does that make sense? Okay, everybody should be paying attention here. Now, the trick that I mentioned already, and I'm mentioning again, hopefully it makes a little more sense here. The negative sign on the exponent, you could easily, look, let me rewrite it. There's a problem written over again. I noticed that there's parentheses with the negative on the outside. I could easily change that to positive and make sure that I flip the inside fraction. It's a little trick. So if you do flip it, you'll have 11 over 9 to the power of positive 1. And anything to the power of positive 1 just stays exactly the same, so your answer is still 11 over 9. Does that make sense? So let me go to the side here. If anybody's 16 years old, when they ask you your age, you could say, when they say, hey, what's your age? Inside parentheses, 1/2 on the outside to the power of negative 4. Because you could distribute the negative 4 and put it here, 1 to the negative 4 and then 2 to the negative 4, but then you have negative exponents, which means you're going to have to flip them, and then you're going to have to expand. Or what I just mentioned right now, if you have a negative exponent on the outside, you could easily just change it and flip the inside fraction. So if you do flip that inside fraction, it becomes 2 over 1, which you don't really even need over 1, it's just 2. And 2 to the 4th power is 2 times 2 times 2, 4 times, which is 16. So 1/2 to the negative 4th power is really 16. Again, you could have taken the negative 4 and distributed, so putting a negative 4 on the top one and putting a negative 4 on the 2 that's on the bottom, and then applied rule 6 where you move, and then you'd end up with 1 to the 4th on the bottom and 2 to the 4th up on top, and when you work it out you get 16. I think it's a little easier if you have a negative exponent on the outside to simply take your fraction, flip it, change the sign, and then worry about the rest. Let's move on to number 19. Okay, so there's many different ways of approaching these types of problems here. First of all, which rule would you like to apply? Pick one. So let's apply rule 5. Anything to the power of 0 equals 1, and we could use that on this first term, k to the 0. So I already know that k to the 0, anything to the 0 power is 1, so I could just scratch it out. I mean, technically it becomes a 1 times, but 1 times anything doesn't change it. So you could just scratch it out. So that's what I'm going to do. I'm not even going to put the 1 times. Now, what about the rest? Right here, you're faced with either using rule 1 that says when you're multiplying two terms with the same base, what do we do with the exponents? You add them, right? Okay. Or you could use rule 6. When you have a negative exponent, you could grab it, move it to the other side of the fraction, and it becomes positive. Yay? So let me show you both ways of doing this. Check this out. I could actually take this k to the negative 6 and move it down to the bottom of this fraction, and I will have a k to the 4th that's up on top over k to the 6th that's on the bottom, and then I could apply rule 7, which means I cancel out these 4 k's with 4 of these, and I'll have 2 left over. So my final answer is really 1 over k squared. Does that make sense? Yes? Okay, now let me go back. I want to keep my answer right there, but let me go back and do this problem a different way. I already know that k to the 0 is 1. And then I could apply rule 1 and say k to the 4th times k to the negative 6. I'm going to add the exponents. So I really have k to the, and let's think about this. What is 4 plus negative 6? What's 4 plus negative 6? That's negative 2. So you really have k to the negative 2. And then you would have to apply the negative exponent rule that you grab it and you move it to the other side. So you really end up with that answer right there anyway, 1 over k squared. So like I've mentioned in this class many times, there's many roads to the same place. You could choose to move the negative exponent down first and then cancel, or you could choose to do rule 1 and then move the negative exponent down. So it's up to you which rule you want to apply first. Let's move on to number 21. Number 21, what do you guys want to do?
Rule number 6.
Rule 6, negative exponents, move them to the other side. I want to get this f to the negative 7, and I'm going to move it right down here. So what's left over up on top?
1.
1. There's nothing there, so I just put a 1 up there. On the bottom, I have the f to the 4th that was originally there, and I now have an f to the 7th that I moved down there, and it now becomes positive 7 instead of negative 7. And now I could apply rule 1 down here. F to the 4th times f to the 7th. What is f to the 4th times f to the 7th? Rule 1 says when you're multiplying with the same base, what do you do with the exponents?
F11.
Add them. F11. That sounds like a bad word. F11, no. F to the power of 11. That's right. Hey, what do you have against the number 11? No, I'm just kidding. Number 23. Of course, they get more fun as we go. Negative exponents, let's move them to the other side. I want to take this f to the negative 5, and I want to bring it down here. I want to take this h to the negative 2. Does h come before g or after g in the alphabet? Before. So I want to take that h and write it before the g. Make sense? So let me start my answer by rewriting the fraction. The g to the 4th power did not move. The h to the negative 2 goes up and it becomes h to the positive 2. And the f to the negative 5 comes down and becomes f to the positive 5. And ladies and gentlemen, that's our answer. H squared, g to the 4th, f to the 5 on the bottom. That's your answer. Let's move on to number 25. Fun stuff and extra tricky. Extra tricky. All right, so anything to the 0 power is equal to?
So you just cancel out 2.
To 1. So let's just cancel out the t. T to the 0, that's really 1. So if you go negative 15 times 1, it's still going to be negative 15. So that's why we could just scratch it out. It's gone. It's not there anymore. Okay? And then negative exponents, we're going to get them and move them to the other side. So on my new fraction, I still have the negative 15 up there, but I no longer have the u to the negative 1 up there. And on the bottom, I still have the 5u to the 3, but now on the bottom, I also have a u to the positive 1 that I just moved down. And rule 1 says when you're multiplying with the same base, u to the 3rd times u to the 1, you add the exponents. So my new answer is negative 15 up on top divided by 5u to the 4th. Now, is there anything else I could do? The answer is yes. Let's look at those numbers. Negative 15 divided by 5. What's negative 15 divided by 5? It's negative 3. And where's that negative 3 supposed to be? Up on top or on the bottom? Up on top. Now, if you're not clear with this, you could always rewrite negative 15 as negative 3 times 5. And then on the bottom, you have the 5 and the u to the 4th, of course. And right here, the 5 and the 5 cancel. That's why your final answer is negative 3 over u to the 4th. That is your final answer right there. And of course, you could write the negative sign right smack in the middle of the fraction if you wanted to. And that is it. So I've explained all the odd ones. You guys' job is to do all of them. All right. So all the work I did, I expect you to do it, and also go back and do all these even ones. That's your homework.